Hello everyone, welcome back to my channel, Predicting the Future. Today, I want to show an example of explaining the Borel Cantelli Lemma using flipping point coins and to explain some of the concepts there. So suppose we have AN, which is an event that we observe ahead. And so the probability of AN is 1/2. The complement of AN is 1/2 as well. It's a fair coin. So because of that, the sum of a probability of AN is infinity. So by the second Borel Cantelli lemma, we know that the probability of observing heads infinitely often has probability 1. So that means we will be observing heads, tail, 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 head, tail, tail, head, tail, and so on. No matter where we start in that sequence, we will still there will be another AN greater than that index. Will still be able to observe a head somewhere. So there will be infinitely many heads that we will observe. Because of that, we know that the complement of the lim sup of AN is lim inf AN complement. So that means that the complement of that event is equal to observing tails eventually all. So that's the same set, and that means that the probability of observing observing tail eventually often has probability 0. So which means that the probability of observing tails eventually all has probability 0, which means that no matter what we have at the beginning, starting from some point M, we'll observe tail all the time. There will be all tails, and that has probability 0. So that's and this is a subset of observing all tails starting from the first flip until infinity. Starting from beginning observing tail until infinity is a subset of this event here. So it's a subset of here because that has a probability of 0. So that observing all tail, it has probability 0. So that also means that if we change the event to be AN to be tail, then that means that the probability observing all heads has probability 0. And yeah, that's it. Thank you, everyone.